Hello, advanced algebra students, and welcome back to another video lesson as we start a new chapter. And we start to think about what are called radicals. So we're going to expand a little bit of what we ended last chapter with, where we started to look at different square roots. Radicals are square roots with different root values. So here's just a quick overview of Chapter 8 and what we're getting into, called inverses and radicals. Again, these square root symbols are the radicals. We're going to have two different mini-tests, one on 3 sections, 8.4, 8.7, 8.8. Second mini-test on 3 sections, 8.1, 8.2, 8.3. Really important to note that all of those tests, both of them, are no calculator. So there's still a lot of work to do, mental math, and understanding the processes that go with them. So in a sense, we're saying bye-bye to these fractional, rational exponents, and more so dealing with these square root, these roots or radicals. All right. And so in order to kind of help us, we go backwards a little bit, where we look at the difference between solving and simplifying some of these examples. This is, again, coming from the new packet on Chapter 8, which is linked out in Classroom. The good news is that we're only going to be using the real number system. We're not using imaginary anymore. So only the real number system. If we're solving x squared, we take that square root of both sides, or the radical. And if we're solving, we get both the positive and negative value of 6. Whereas if we simplify 36 to the 1/2 power, again, that is taking the square root of 36, or radical 36, but because it's simplifying, we only want 6. Same thing here, we only want 6. All right, if we're trying to solve x squared equals negative 49, we take the square root of both sides. However, we're only dealing with real numbers, so this has no solutions, because the solutions would be imaginary. If we tried to simplify any one of those also where there's a negative underneath, we would also have no solutions. All right, and you'll see that they're very common across these rows here. X to the 3rd to the 27th. Again, we can take the cubic root to solve. Right? We could raise it to the 1/3 power, or looking for that cubic root of 27, which is 3. 27 to the 1/3 power is 3. The cubic root of 27 is 3. So again, pay close attention in this chapter to solving versus simplifying. And remember that we're only going to be working with real numbers. Now, one of the important properties, and we really did touch on this a little bit in the end of last chapter, is that if I have the nth root of some value of x, that's the same as saying x to the 1/nth power. X to the 1/nth. Now, this only works if the value underneath is positive, if that x value is a positive number. And again, we did a lot of work with this in our last chapter in helping us simplify and solve. But now we're going to focus on just these positive values and how they operate going back and forth. This piece becomes very important, x to the 1/nth, because of the property that we learned way back a few chapters ago, that if I take x to the 5th to the 3rd, we really have x to the 15th. Same thing if we're using fractions, okay? So if we are trying to simplify some of these or rewrite them, the 5th root of 32 is the same as saying 32 to the 1/5 power. Or the 4th root of 16 is also the same as saying 16 to the 1/4 power. And being able to go back and forth between these is going to be very helpful as we get to working with more complex radicals and inverse functions. All right, so here's 3 what I'll call old news review problems. See if you can't simplify those 3. All right, the 4th root of 81, again, that's like looking for 81 to the 1/4. So what number times itself 4 times? Well, that would be 3. The 5th root, so again, 243 over 32. Both of those being raised to the 1/5 power. We're looking, in a sense, for the fifth root of 243. We're looking for the fifth root of 32. 243 is 3, and 32 is 2. The fourth root of x to the 18th. So the easiest way to look at this one is to say x to the 18th raised to the 1/4 power. Right? That fourth root means 1/4 power. And what do we do with these two? Well, we multiply them. And we end up with x to the 18 over 4, which we should simplify. Or we get x to the 9/2. So this property right here is where we're going to focus a lot on what we're doing today. Okay, what is the cubic root of the square root of 64? The cubic root of the square root. Well, if we change, right, if I look at the square root of 64, okay, I know it's 8, but I want to look at how do we change that to a fraction? Well, we raise it to the 1/2. 64 to the 1/2. Okay, and because of that, we can kind of replace that square root of 64 with 64 to the 1/2. And then we're taking the cubic root of that. But the cubic root really implies that we're taking whatever underneath the radical sign, 64 to the 1/2, and in a sense, we are raising it to the 1/3 power, or 64, and we multiply a power to a power, 64 to the 1/6. So the sixth root of 64 is 2. Okay, and we could do that by saying the square root of 64, well, that's 8. And then what's the cubic root of 8? Well, that's also 2. But knowing this property rule, which is this important note down here, is going to help us. We are going to end up multiplying the numbers on the ledge, right? This was a 2, even though it's not written, and that's a 3. So if I multiplied those, I would have the sixth root of 64, turn it into a fractional exponent, 64 to the 1/6, and simplify it to show that it was 2. Okay, so multiply on the ledge and then turn it into a fractional exponent. Let's take a look at this one. Rewrite it without radicals. So basically that means rewrite it with a fractional exponent. Well, there's a 2, a 2, and a 2. So I multiply the numbers on the ledge. 2 times 2 times 2 is 8, or the 8th root of 8, which means 8 to the power of 1/8. 8 to the power of 1/8. How do I write it with one radical symbol? We kind of did over there. We're looking for that 8th root of 8. Okay, so multiplying the numbers on the ledge, 2 times 2 times 2, and then writing it as that fractional exponent. Why don't you give these, what are there, 4 of them, a try and see what you come up with. Letter A, without the radical. So again, there's a 2 and a 2 and a 2, so that means an 8. I'd have an 8th root of x, but without radical, so without a square root sign, means x to the 1/8 power. And that would be what we call simplified. Letter B, if I'm looking for the 4th root of the 3rd root, that means I'm looking for the 12th root of y, but without a radical sign means y to the 1/12. Now again, as long as x is greater than or equal to 0, well, greater than 0, it's got to be positive, and as long as y is greater than 0. Okay, simplifying. The square root of the square root of 16. So that's the 4th root of 16. Or 16 to the 1/4, which is 2. That is 2. Here, letter B, we've got 6 times 2, so that's really the 12th root of y to the 36th. But that, as a fractional exponent, is 1/12. And what is our property for a power raised to a power? Well, we multiply them, and we would get 36/12. 36 over 12 is 3. And so we're using a lot of this power to a power property after we've multiplied the numbers on that ledge or that shelf. If you have any questions, please make sure that you reach out. Otherwise, until next time, everyone, stay safe.